Tukwa from the Energy Office. This is one in a series of video vignettes, and today I have Professor Antonio Castro-Neto, who is head of the Graphene Research Center. So I'll pose to Antonio a few questions, and then we'll go from there.
Okay.
Briefly, Antonio, tell us about the evolution of this center until your most recent award from the National Research Foundation.
So we started in 2010 with a grant from the National University of Singapore to start operations. With that grant, we built many facilities, including this one, our nanofabrication facility. During the periods from 2010 to 2013, we were very busy, and we were able to attract quite a substantial amount of funding to the university to do the research here in graphene. And we have had great results. We have published in the best journals. We have been able to attract funding from the industry to work with us. And in just June, July this year, 2014, we were awarded the Mid-Size Center grant from the National Research Foundation. So now the objective of this grant is to look at materials beyond graphene, but also these materials are two-dimensional in nature, which means that they are atomically thin, and they have functionalities and applications that are different from graphene, and in fact can complement graphene in many ways.
Fantastic. Actually, you beat me to the question I was going to ask you, because I heard you give a seminar and I was very impressed that you've taken these two-dimensional structures and looked into the fact that just being two-dimensional, they lose some of their bulk properties and all that. Could you, at least for the layman, talk about some of the applications of graphene and these 2D structures?
Sure.
And then for the layman, explain how, because we live in a 3D world,
correct, how
they could be supported and whether support structures can affect the electronic properties of these things.
Okay, so in fact these materials are three-dimensional, but they are thin as one atom. So that's why we call them two-dimensional. But of course they have the thickness of one atom. These materials are very similar to plastics in that sense, because they are so thin that they are also soft. They are so thin that they are transparent. Okay, all of them. Nevertheless, some of them are conductors of electricity, some of them are insulators, some of them can actually become superconductors, which means that they can conduct electricity without any loss of energy, and some of them can be magnetic. Right? We are surrounded by this kind of materials around us. Our computers, our cars, our microwaves, everywhere. We have materials which have this functionality. The only difference here is that these materials are so thin that you can reduce the volume of any kind of device to atomic scale. Okay, so the best analogy I can give you is that you can think of these materials as kinds of plastics, but with many different functionalities. Okay, so this is why the industry is so interested, because the number of applications are huge. It can go from simple applications like paints and coatings. For instance, anti-corrosive paints for ships. It can go up to even microprocessors. Okay, so I would say that this two-dimensional material area is more like a platform for many different industries, because essentially you can pick and choose whatever application you want. The only difference is now we're talking about materials which are extremely thin. I guess that's the best.
And that was the question that I wanted to ask. It is extremely thin. and therefore you have to put them on support structures for a lot of things.
Correct.
How would they, some of their properties compromised in this way?
So this is a very interesting question. So it depends very much on the application. Okay. So for instance, for let's say flexible electronics. So flexible electronics is essentially devices which you can fold, you can roll, and so on and so forth. So usually the substrates of choice is plastic, for instance. But if you want to use these materials for coatings, you don't need a substrate. You just essentially can spray or transfer the material directly to the surface you are working with. Okay? So it really depends on the application.
So you've given us very interesting approaches. Off camera, I'm going to interview your business development person.
Sure.
First of all, thank you very much for giving us the excitement, and I hope your colleague will give us a more, what would I call it, a more business view to things.
I hope so too.
Okay.
Thank you very much.
And again, Antonio, thank you very much.
Thank you.
Thank you.
Thank you.
Okay, this is a follow-up of my interview with Professor Antonio Castronito. I'm now meeting with Tricia Chong, involved in business development for the Graphene Research Center. Tricia, so give me a few examples of market areas or market segments that you are targeting for graphene and perhaps the other 2D materials.
Coatings is probably one of them, because specifically for graphene, it demonstrates the ability to be anti-corrosive. So some businesses, startup companies and all that, they're actually looking to that area of application, developing concrete materials that could serve as coatings. In the line of coatings, it can also be explored for life science applications, because some of these implants may actually pose as a problem for long term in the human body, in vivo. So graphene specifically, being biocompatible, has the potential to bring forth implants in a safer way. Of course, there are other areas that most people are exploring as well, replacement of carbon in battery materials. As much as the much touted discussion of graphene being used in electronics and display, but that actually is a longer term development than things that I've mentioned in coatings and composites and things like that.
Okay, so you're talking about coatings in the outside world as well as in vitro. So one last question on it. Now, in the outside world, when you have a monolayer of stuff, what's the resilience of these coatings under impact, abrasion, all of that?
Well, actually, the graphene specifically can be produced in two ways. Most people associate it as atomically thin film, and it's large sheets of it. But it could also exist as platelets. So when you put them in coatings, it's just having them evenly distributed in the vehicle that carries it for whatever purpose to be applied. Not necessarily a uniform single sheet that goes on top of any surface. So to answer your question about the kinds of applications that may be derived, I think there may be some overlaps between the use of graphene as a composite in as much as by itself as a coating.
Okay, so there we have it. We have graphene from Professor Antonio Castronito and now Tricia Chong telling us the basic science excitement of graphene in 2D structures and possible near-term applications in coatings. Thank you very much.